So hi, in today's lecture, we are going to learn how to check whether the given linked list has a palindrome in it or not. Okay, so if we take a look on this example, here we can see that the data in this is 1, 2, 3, 2, 1. So this is a palindrome. I believe you know that what is palindrome. And if we take a look on this linked list in which is it is a size of an even, so 1, 2, 3, 3, 2, 1. So here in this example also it is a palindrome. Okay, so we need to return true. If it is not a palindrome, then we need to return false. Okay, so I believe you got the question. Now how we can solve this? See, the brute force approach is that what you can do, you can take the linked list, like let's say this. Okay, and after taking this, we need to traverse an entire linked list, and while traversing you can copy this in a array. So 1, 2, 3, 3, 2, 1. So this is an array. Now inside the array you need to check whether it is a palindrome or not, and this can be done with the help of two pointer technique. Okay, so here we will be having one variable which is pointing to the first element and the second variable which is pointing to the last element. If they are both same, then you need to move this I towards right hand side and this j towards left hand side. So basically I will be incremented and the j will be decremented. Okay, again if they're both equal, then again increment the I and decrement the j. Okay, again here also we can see that they are both equal, so increment the I and decrement the j. Okay, now here we need to stop it. Okay, so the condition would be that I shouldn't be crossing j. Okay, I should be lesser than j. Okay, so if this condition is false, then we need to terminate the loop and simply we can return true because it is a palindrome, right? So in this way you can solve this problem. So this will be the brute force. So the first step would be that traverse through the entire linked list and copy all the elements into an array. Now the second step would be, with the help of the two pointer technique, check whether it is palindrome or not. Okay, now I have shown you that how to traverse into the entire linked list. Okay, and with this approach as well, whether to check whether the given array is palindrome or not. Okay, so let me talk about the time complexity. So this will be going to take order of n time. Okay, and this is also going to take order of n time. Okay, so combining this two will be 2n, so the time complexity will be order of n. Okay, and what about the space complexity? This will be also order of n. Why? Because since we are copying all the data, okay, in the new array. Okay, so due to this will be the order of n space. Now the interviewer will not be happy with this. Okay, so we need to optimize this such that the space complexity will be order of 1 or constant. So let's talk about approach 2. Okay, now let's take the above example only, which is this. Now see over here, what we can do, we need to check that whether over here also we can able to apply two pointer technique. That means one variable will be pointing to the first node and the other variable will be pointing to the last node. Okay, so if they are both equal, okay, we need to increment our I to the further node and we need to decrement the I to the previous node. Okay, but here we can move this I towards the next, but since this is a single linked list, okay, so I am not able to go backward, right? So what I need to do, see over here, if I take a look on this part, okay, in some way if I reverse it, that means over here I can see that 2 is pointing to 1, but what if 1 is pointing to 2 and 2 is pointing to 3? Okay, so when my j is pointing to the last node, so with the help of this I am able to traverse on the backward side and so on. Okay, so what I can do, only to this part, okay, I need to reverse it so that 1 will be pointing to 2, 2 will be pointing to 3, and 3 will be pointing to null, because this will be the last node. Okay, so I already told you that how we can reverse the linked list. Okay, so what I'll do, I'll be just passing this as a head, okay, and I will be reversing only this part. Okay, so it will look like this. Okay, so now for this second part, okay, the first node was 4k, okay, and the last node was 6k, but over here now the first node will be 6k and the last node will be 4k. Due to that, this node is not pointing to anywhere. Okay, so now what I'll do, I will be having p1 that is pointing to the first node, and this p2 will be pointing to the last node. Okay, and then I will be traversing it by going to the next, and if I found out if any of the value is not equal, that means p1 of value is not equals to p2 of value, then I will be returning false. So over here I can see that both are equal, so I will be traversing like this. Okay, since for this the next node is this, right? So hence I'm able to traverse now. So over here also I can see that they are both equal, so traverse it. Okay, now where I need to stop, see, since p2 is pointing to this last node, okay, now if I'm traversing p2 again, okay, p2 will be pointing to the null, right? Because for this the last node is no one, right? So I need to stop it over there. Similarly, if p1 is pointing to null, I need to stop over there, right? So this will be my stopping condition. So I hope you got this. Now the next question arises, that how will I get to know that where is the midpoint so that I can reverse this part? Okay, the answer is very simple. We need to apply the hare and tortoise method over here, okay, with the slow and the fast pointer. I hope you got this. All these things, all the prerequisite I have explained in the previous lecture. I'll be putting down the link in the description box, okay, so you can take a look now. So let's write a pseudocode. So the first thing that we need to find the mid node. Okay, so fast pointer will be head initially, and slow pointer is also head. Okay, now while loop, over here the condition will be fast pointer should not be equals to null, and fast pointer dot next, it is also should be not equals to null. Okay, again I'm telling you that this I've already taught in the previous lectures. Okay, now slow pointer will be jumping one at a time, and fast pointer will jumping two at a time. So fast pointer will be fast pointer dot next dot next. Okay, now by the end slow pointer will be at the middle. Okay, so I got the middle. Now with the help of that node I need to reverse it. Okay, reverse the half. See, slow pointer will be pointing over here, so I need to reverse this. Okay, now the slow pointer will be the current node, the forward initially will be null, the previous will also initially null. Okay, now I'm going to reverse the half part. While current is not equals to null. Now forward will be current dot next, and current dot next will be previous. Okay, after that the previous node will be the current node. Okay, and the current will be forward. Got it? So this is for the reversing the half part. Okay, now what will be the head, or what will be the first node of the half part? Okay, that will be stored in the previous variable. Okay, so the last node will be the previous. Okay, and I'm creating a new temporary variable that holds the head. Okay, now I'm going to apply the 2-pointer in which this node, the previous node, which was the head of the second part, will be the last node. Okay, I mean to say this. Okay, this will be the last node and this will be the temp. Okay, now I'm going to match each and every value, and then I'm going to move temp to here and last node to here. Okay, so while temp should not be equals to null, remember I told you this condition, and last node should also not equals to null. Okay, and there is one more condition, that temp should not be equals to last node. Both the address should not be equals. Okay, now if I found out that the values are different, I'll simply terminate the loop and simply return false. So temp dot value is not equals to last node dot value. So I'll return false. Okay, if this is not the case, then I'll simply have temp is equals to temp dot next, and last node will be last node dot next. Okay, and that's it, we are done. Okay, if we have gone through all the nodes, okay, that means the given linked list is palindrome, so we can simply return true. Okay, so I'll write here again that this is for finding middle node. This is for reversing half linked list. Okay, and this is for checking palindrome using 2-pointer technique. Okay, now if I talk about the time complexity, see, this is also going to take n time, this is also going to take n time, and this is also going to take n time. Okay, approximately n. Okay, so it will be 3n, so the time complexity will be order of n, and here we have not taken any space extra, so the space complexity will be constant. Okay, so that's it. I believe you got it. If you haven't, please take a look on this code and try to dry run it again by yourself. Okay, so that's it from my side. I'll see you in the next lecture. Till then, keep practicing. Thank you so much.